Before we actually use Solver to optimize this model, let's go ahead and clear out the controllable cells. We have decision cells representing the number of employees we hire, fire, and our production costs. So we end up with a cost anyway of over $1 million, but of course this doesn't make any sense in the sense that we have negative inventory and obviously we're not meeting our production goals. So let's go back into Solver. So under the Data tab, Solver. It's going to be a little bit of a big window to deal with here. Now, a couple things we can leave as is. Our total cost we're still minimizing. We're still controlling soccer tables produced, but now we have additional controllable cells. We can add these with a comma and then highlight the next cell. Now, how you highlight this is more of a matter of taste. You can highlight both groups, number hired and laid off, or you can include one and then comma and then include the second one. I would probably go with the latter approach simply because that allows you to name these more specifically. So when you have range names here, which you ultimately need to be doing very soon after you finish this model, you now could have controlling production, employees hired, and employees laid off. And it would be very clear to the user what effectively you're doing. Our ending inventory is still limited by our maximum inventory, and production is still limited by the labor capacity. And our ending inventory still has to be greater than or equal to 0. So those are all still valid constraints. But one thing we need to control, obviously, or we added as controllable, was the employees hired and laid off. And we do require that those be whole numbers. So again, I'm going to handle these separately because I have them in the decision cells as separate entries. So each of these are going to be integers. Let's hit add. Let's go ahead and include laid off as another group of cells that need to be integers and hit OK. Note that I put on these integer constraints after I already added these cells to the changing cells list. It has to be done in that order, or Solver will come back with basically the idea that you cannot add an integer constraint of something that is not a changing cell. Because this is an integer or has an integer constraint, we need to go to the options. We need to make sure that the check for ignore integer constraints is not there. And at this point, let's go ahead and take our integer optimality percentage all the way down to 0. Hit OK. We are now ready to go. This is still a simplex LP or a linear program, and we still don't want any of these values we control to go negative. Hence, the check remains on that box. Let's hit solve. You can see Solver found a solution. We've met all of our constraints. Hit OK. And you can see our 6-month production cost is now at $1,142,000 and change. We're now hiring and firing on a month-to-month basis. And you can also see that our production now is probably much more flexible and more closely meets our actual demand. You can also see the ending inventory effectively goes to 0, although we still use a good deal of our inventory storage in month 2. But overall, we have a nice production cost, and we're incurring less cost simply by the ability to add and subtract employees in this model.